For this 24 hours of chaos, we brought one of the greatest specialists in artificial intelligence applied to CG, a guy with a lot of experience with deepfakes, AI rotoscopy, and all sorts of crazy stuff that one can only imagine that can be done with AI in movies and CG in general. So let's welcome Thiago Porto.
Thank you.
This is so amazing.
I've been rehearsing this introduction for the past
I was
few
going.
weeks.
Sorry, I was like, okay,
Wow.
I have a first question before. Okay, like how many times did you practice that? Because that was
Yeah,
amazing.
this is insane.
Yes.
It's literally insane.
So,
Yeah, thank
Thiago,
you so much
thank
for
you for
inviting me.
joining us. I
Of
know
course.
it's a live event. It's crazy, like to talk to people in English, but you have so many different and interesting things to talk about with your work with
Thank you.
artificial intelligence, and it's something that's so in vogue right now. And people are always, like on the internet, people are going crazy about that. So I would love to hear you talk about artificial intelligence. And to
Mhm.
start, I would like to make a very, very basic question,
Mhm.
which you guys know I'm famous for. What the hell is artificial intelligence?
Uh, I knew this would be.
You saw that coming, right?
Yeah, I saw it. First of all, thank you so much for the invite, guys. It's really amazing to be here. So thank you so much. All right. So what is AI? This is a tough question. First, artificial intelligence. It's hard to find the right answer for that because there is books. There is people imagine it because it's so many movies and stuff. So it's hard to tell like what is, but it's like humans. What makes our special? It's sometimes hard to tell as well. But what I can say that in the moment there is no artificial intelligence per se. We are going there. We are moving to go there, but still there is no kind of intelligence like a human intelligence. It's more like uh, uh, analyzing and learning from data and things, and then trying to replicate that how our human brain works, which is neurons. So you have neurons like biologics saying like you have neurons connecting to neurons inside of your brain, and then that electrical power, it's kind of your you know intelligence. So that's why that came like neural networks. But I don't think we can say like we do have artificial intelligence yet. We do have intelligence, very smart networks that try to predict that. So yeah, it's that's what I think we are right now. Yeah.
Okay, so I don't have to be afraid of like Skynet becoming a thing, right?
Hmm. Alrighty.
Okay, you hesitated for too long.
Right. Okay.
It's I think we should in some instance, yes. Not like, oh, the machines are going to be against humans and love that. No, we are not there yet. But the level of how you can imagine and you can analyze data, you can turn the data into a meaning, and then doing something with that data, it's beyond what humans or even like this huge amount of teams can do it right now. We passed that a long time ago, like 5 or 6 years ago, where the machine can really understand the meaning of a data set and then do something else that humans, it's really hard humans achieve that so quickly. We have examples like that, like game, where we see like artificial intelligence uh playing chess again a human, and the human loss is because it has so much data. It can it can understand that data and can analyze that data so much faster that the machines already passed that in terms of analyzing data and analyzing the meaning of the data and give you an answer. So if you're thinking in that way, we already have machines kind of smarter than humans. So
Be scared.
yeah,
This
I
is
actually
amazing and terrifying.
I can give you an example. I prep a video which I can show you. what I mean, like having a data set and how machine can understand the data set. So I prep a video that I think it's easy to visualize.
Hmm.
Let me see if I can share screen, window, and here share. So let me know when you can see the screen.
Yeah,
Yep.
we can
Cool.
see it. Yeah.
So this is all the steps of training a AI. So first we need data. This is all what this powerful machine learning the neural nets needs. It's data. So in this case here, uh, is training a machine to understand like fruits like apple, like like lemon and all of that. So what needs, this is very like today is a simple task for machine to do, like recognize and do something with that. But this is how the process is. So first we need data, so we need to feed the machine with lots of apples, with lots of bananas and lots of variation of the same apple, the same lighting, because that is the way human can do very natural. We can see apple like with very shade and bad lighting, recognize that that is still an apple, and computers can. So the only way they can do that is having data to go back in the past and say, oh, okay, so that looks like an apple because I saw that before, and that's the way I know that this is an apple. So this is where this is how we train AI. It's with a lot of data. So this is an example of that. So you see, it's a
Yeah.
you see like
Hmm.
different pictures, different lighting, variations, rotating. That's is what make like a machine learning model very robust. It's fitting with data over and over again with different lighting, different scale, position, perspective. So you get the variation, so the machine can go back and see, okay, so one of the variations matches. So this is, so now you do this huge amount of data, which is just pictures, and now machine can
Hmm.
learn for that, and that is what's happening now. So this is kind of how our brains works in some extent. So you have layers of neurons. So like each layer of this will do something. So for instance, this is our input. So this is an image, and it's by three because it's RGB. So you have like red, green, blue. So that's why it's by three. So you have three layers here, and that goes to a layer, that kind of a neuron, and then that gets analyzed, and then goes to another one, another one, another one. It's kind of how our brain actually works as well. We always sending and back energy. So that's why the name neural networks came, because it's very similar. So this is just a visualization of it, and this is kind of the code. So this is just like a way of showing what's going on in the network. So what you see is like we are feeding, and then you have layers of layers of layers that you're gonna do something with that picture or that data. So you see, you have the apple here, and each of these layer is analyzing something different that can detect layer and understand
Hmm.
that it's apple. Same goes to the onion here. So this is a big neural network. So you see how many neurons or layers you have. And this is actually how our brains works as well. It's just like, you see, so many layers.
Hmm.
And so this is how neural network works, like kind of our modern AI works. And in the end, what you have, like, you have your input here, and then you have tons of analyzing different colors, different things that are gonna make that unique. And then the size, you have like, I don't know, 100,000 pictures of the same thing, that gets very robust. And kind of, it's kind of how we do it as well. We learn that by when you are babies, to you see, and then get the word like, oh, this is an apple, this is an apple. Eventually we're gonna know that it's actually an apple.
Hmm.
It is. So this, I think it was a way of showing you how visualize. Yeah, let me stop sharing.
This
Wow.
is cool. This is very cool. Let me ask you something.
Mm-hmm.
Once you teach okay, this is an apple. All right, this is not
Cool.
an orange. This is an apple.
Mhm.
This is a green apple. This is whatever. What are the uses of AI once it learns what's going on? What's an apple? What can you do with that information? What kind of things can you do with that information? Because I've always thought of AI as like a brute force approach to certain tasks. For example,
Mhm.
if you're doing rotoscopy, it's like I want to select every apple in this scene. So instead of me
Mhm.
going there and drawing a lasso selection or whatever to every frame, I just tell the computer, do you know what an apple is? Go and select them. Can you elaborate on that?
Yeah. So imagine it for a second. So if you can train a model to understand apples, onions, whatever, you have a very robust model that right now you can use, for instance. So give me a mat of an apple. And because the model knows how to look to an apple, it's gonna give you a roto of that.
Hmm.
So
Mm.
that is one case because since you train and the model learned the meaning of what is the apple because so many pictures, from that point on, you can use that data to do something else. And if you want roto, you can say, okay, this is a roto, so give me that. And then it will every time you feed a shot, you're gonna look for apples because it learns how to look at. Otherwise, you know what I mean? It's comparing, and
Hmm.
that is this thing called vector space. It's where all this information, knowledge of the AI is, so it can go there and look and say, "This is not an apple. Don't give me a mat. This is an apple. Give me a mat." So essentially, that's how Roto AI model works. You train with so many examples, and then eventually you're gonna learn how to look at that, and then you can, push to do like a mat,
And how,
essentially.
and how long does it take for the machine to learn the meaning of apple? That's a deep question. Uh,
Yeah,
It
a lifetime.
depends of the how good you want. For instance, for a driving car system, you don't need that roto of the apple to be very consistent. You only need to know that there is an apple in there. But if you want to rotoscoping to do VFX, you really need good edges. So that is a big difference because you want the model to really be robust and look for and give a consistency. So if you want like a consistent, that can take easily uh, on a single GPU can take like, I don't know, 30 months to 5 years. And
ah, what?
yeah, and a
I
single
just fell off my chair here. What?
yes. If you want something, let's say, if you want something faster, which everyone wants to do that,
Yeah, why
can
would
take,
it? Why would you
yeah.
want
So,
something faster?
and that's where you see data centers start to building up and be very like unique business because you can say, I want to train a model to recognize apples and do math, and I have 300 GPUs. So that is not going to be 5 years anymore. That's going to be like a year, maybe. No, I want to have 5,000 GPUs. And that is exactly, for instance, what Tesla is doing in all of their cars. So they run a model to recognize, and they train on top of that, and they build one of their latest warehouse build they build with 6,000 GPUs, and so
Wow.
they can train like a 10 minutes clip in a matter of 5 days. So because you have so many GPUs, so that's why it's a shortage out there. It's also AI.
And since you
Yeah.
mentioned the GPUs, I happen to know for a fact that you kind of sport a collection of GPUs, right?
Yeah.
Uh, because you actually need a lot of GPUs in order to do that kind of work. And that leads me to a question that we got from I think it was on YouTube. What sort of uses are there for AI in solo artists and freelancers workflow that everyone should get into doing? And before answering that, I'd like you to talk about the investment made in AI. If you want to actually dive into that sort of
Mhm.
stuff, how much does it cost to have a decent setup so you can actually do something? Because of course,
Mhm.
I have my GPU here. I have a 3080. oh, it's cool, it's nice, it's expensive, it costs a liver or two. I don't know, but uh, how can one afford? Is it affordable right now, or what can you do with an affordable setup?
Okay. So when you are playing with AI or deep learning or machine learning, you have to decide where you want to go, because or you can train your own models. So let's say you want to build a data set and then you want to train that and then you want to apply that. So that it's where it gets like you need thousands of GPUs, or a couple of hundreds of GPUs and so on. But that is the other part, and that is where CGRs are starting to see more and more and more, especially with real-time engines and stuff like that. It's, for instance, V-Ray now has like this amazing render of Doomy lights and machine learning stuff coming out. That's all based on data set. So what once you train your model, you have this model ready to go. To use that in a new shot, you don't need computer power. That can be easily running like just a single machine or a single GPU. So that it's where the industry is running to. It's like a few players train their models and they put you on the app, Maya, whatever, and then you can use that pretty much on your single GPU. So you're not training, you're not doing anything, but you're actually applying AI that was training before, a model that was training before. So answer to our question, for a solo artist, I think it's about running those models. It's not about training those models. So either you have to wait, or you're gonna see some. I think we're gonna see more and more plugins based on models. And then, for instance, oh, I have this amazing plugin that helped me on rigging my model. It's magical. I press the button and recognize where the feet and the head and the eyes are. Why? Artists doesn't want to care why. They just want to press the button and that's going to happen, and then that's why they're going to buy that plugin. So essentially, probably that plugin was trained with lots of human data, and then after that is trained, it's easily to run by any artist by a single GPU. So the investment depends of what you want to do. You want just inference that, so just running it, or do you actually want to train and build your own model? In my case, I decided to go to build my own models because, in my opinion, in the way I'm envisioning, it's like it's me as an artist, but I also as well have these AI models that can help me in my work, and no other artists have it because I train my own. So it's different. So that's the way I approached this like 3 years ago, and then I started learning these things. Uh, yeah, it's because of that essentially.
So you're basically telling us that if you have access to the models that have been previously trained and know
Hmm.
the meaning of stuff, you
Hmm.
can do. You are like on the same level. Let's put it that way, as big corporations, as big studios and stuff like that.
Yes, I have a good example of that. It's Netflix. When Netflix started doing online stuff, they keep asking people what type of movies they want to see it. So they could related those feature films, TV shows, and put it back to them so it could be easily find, like in the homepage. That never worked to Netflix simply because people lie on the feedback because they are afraid, or they say never works for Netflix. But how it works now, because now they have data of people watching, of you watching stuff, even if for 2 minutes, if for 10 seconds, it's you watch the whole series. So what they do, they have models that they train for themselves, and they are running live, so they can. It's called recommender system. It's the same system that goes like in eBay and stuff like that. So, and that was the event that make Netflix think we need machine learning house. But that it's a unique case where they really need like train, and they have the data to train. So and but once that is training, you see like you running on your app on your TV is running live. So once that is training, it's super easy. But the training and the data access is where it's really difficult.
Got
Hmm.
it.
Does
I
anybody
can
want
show you
to ask
something.
something?
I do have a question actually.
Go.
Should it?
So I think Photoshop has some AI tools right now. I think it's on
Mhm.
beta stage. So it's basically like what you told us, like they
Yeah.
learn the thing, and
Mhm.
that's the part that consumes like a lot of GPU. But for theirs, like the end of the end users that only use the tool, we only need one, right?
Yeah. Sometimes
So
even just CPU.
oh, cool. So
Yeah.
based on that, like multi GPU and single GPU, and now that you meant CPU, my question is, why GPU and not CPU?
That's a really great question, and that starts like around 8 years ago when a company called Nvidia.
Oh, never
Who
heard
are
of.
those? Never heard.
Interesting, yeah. So they they some of their they found some people that had this idea of train neural networks, because neural network is not new. They are here before even like these fancy GPUs. Neural networks in computer vision, it's like 20 or 25 years they trying to do this in computers. But what Nvidia find out like that, it's to if they could build some specific, because when you are in a neural network, it's specific calculation what it's doing, like in the first layer you saw that visualization, you have some layers, so those calculations just math, it's calculating going back and forth. So what they decided to do is like, instead, because CPUs are built to calculate a lot of things from simulation to run the computer, whatever, we could build these GPUs with specific cards that can calculate those specific maths. And then and that where they invented the CUDA cards. So essentially the CUDA cards came from
Oh.
there.
Mm. And that reminds me of a talk by Brad Peebler from Luxology, one of the creators of Moto. And I remember it happened like, I don't know, like 10 years ago or so. And he said that he couldn't at that time see a future for GPU rendering because it was really, because it was like, it was a brute force approach and it was not that efficient or something like that. And it's nice, it's incredible to see how technology evolved in that, I don't know, like 14 years or so.
Hmm.
And you mentioned the NVIDIA, and we see like every day NVIDIA is releasing videos showing new approaches and new uses for AI technology. For example, last week they released a video with natural speech, right, showing
Mhm.
this AI generated voice speaking like a normal person. And there's another video I saw. I don't know if it's old or new because I saw it like 2 weeks ago. That a computer was running GTA, Grand Theft Auto, the video
Mhm.
game,
Hmm.
using nothing but artificial intelligence, meaning that they were not generating geometry. There were no like maps or whatever. There was a description of a scene. It was like there's a car, like I don't know, you name a car, and it's driving over a bridge, and there are mountains on the back, and on the right there's like a beach or so. And they were actually playing GTA or whatever it's called,
Mhm.
using this neural network, using
Mhm.
a custom generated image generated by AI. Do you think that this is a reasonable approach? I mean, instead of having 3D stuff being made, for example, because we do that, right?
Yeah.
Victor is modeling his own characters. I'm modeling, ArcViz stuff and stuff.
Mhm.
Do you think we will end up telling the computer what we want? For example, in my case, I do ArcViz, so they like, okay, I want a house, I want a room like this with a wall here, and we end up like describing what
I
we
will
want
starve
instead
to
of
death if
actually.
that happens.
You will, because you hate
Yeah,
pulling
but
vertices, right?
No, I hate describing things. I hate it.
okay, but just saying that it's already happening 2 years ago. That is
Okay,
not
go.
new for AI. So,
I'm killing
so
myself.
okay, so that is two type of networks. That is style GAN, which is what it's GANs, which I can explain later, and that is also GPT, which is language models. It's models to use in Alexa to language to talk. So what's happening is 2 years ago, some researchers find how to combine those two models together. So what's happening now? It's this boom of technology about you type things and that gets generated. Because remember when I saw the visualization that we got the data set to train, and that was just about apples and stuff. But what happened if you train a model on faces? Or what happened if you train a model in houses? But what happening if you are a social media company with people posting photos all the time, and you have that photo to train your own model? Well, you know what I mean? And then what is going to happening is you're gonna get a model that no one else have, because you have some data that no one's have. So because of data in the past 5 years became something huge for some companies, you're able to train models and replicate, and once the machine figure out how to once the machine figure out the meaning of the data, it can just replicate that. That's what happened with GTA test that we just talking about. Essentially, because the machine learns what to look at for, it knows buildings, knows streets, and know everything. Once you plug a game and you already train a model, so it's easy to just inference, just run. The model is gonna look every time you see like the picture of the game, you're gonna try to replicate that because it has the data. And let me quickly show you something I think you're gonna like. Can you see the screen?
Not yet.
Not yet.
That's it. Cool.
Oh,
Yep.
now we see.
Okay, so this is, for instance, the same style, same GANs models that was training. It's so many thousands of faces from social media, and then you have this incredible model that knows so many different faces, and because it knows so many different faces, it can generate brand new faces. And if you can control that, we can do something else. But not only about faces. If you have data about buildings, if you have data about skies, you can also generate that. And this is what's happening right here. It's like the model can generate different faces, and also it can generate age, because now some people I don't know if you guys remember, like a few years ago we have this 10 years challenge. It was people was posting photos about
Mhm.
I am 10
Oh,
years
okay.
young. So why
We were
now I can
fooled
now
by
do
it.
like I can do like a young to to age, and then you can change the
Wow.
gender maybe, or you can change the color. And here again, if you train the model to recognize features and then reproduce, maybe you can do like a thing, generate real from structures or something like that. Same
Mhm.
goes here. Was a model that was training illustrations, and then also once you train and then thousands of illustrations from ArtStation, you can now do some example. So this is examples, and then you can go between them, and then the machine can eventually know how to morph between each other because it knows what is a paint look like. So this is what's happening here too. Same goes here.
And if you guys notice, we are all seeing all those nice little apps you have installed on your phone
Oh yeah,
that
totally.
make you look like a cartoon, like a Disney
Yes.
character, like an old person, like a female if you're a male, and stuff like that. And that is us giving this
Hmm.
company's information
Feeding.
so they can train their AI models.
Yeah,
Uh,
let me show you
Tiago,
something
we
real
have
quick.
we have 2 more minutes.
Okay, I can show you something now. I didn't have a chance to go into CG AI for CG. Sorry, but just to give you an example here. So this is the iteration 0. So this is where the machine will start, and then eventually we want to modeling and generate a render of a car, of something, and then because was training so many cars, you can control that by doing this.
Wow, 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 wait, 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 wait.
and then boom, this is your render based on your renders that was online. Just saying. uh,
Okay. Okay.
as same goes here. Let's do it. So those images you are seeing are not real. They are rendered from the AI that learn from your renders online.
Oh
Oh my
wow.
god.
So yeah, faces here again, and
This is not even fair.
yeah, same go here shirts. So many pictures of horses, and it's all about data. So as long you have data to train those models, let me see. Uh,
Just to add, I was seeing the YouTube channel 2 minutes paper,
mhm.
some papers about material differentiable shading. It's like
Yeah,
a way to you use an image and then the computer do all the texture and shading for you from your reference. It's
Oh
from
and
machine
wow.
learning.
you
Guys,
know,
I sadly I have to stop us right now because we are running out
right?
of time. This is a subject for like 2 hours
Yes.
of talk. So, Thiago, we have to do another episode of the V-Ray Master Talk.
You're welcome.
That time in Portuguese, all right. But
Mhm.
let us know in the comments if you want another episode in English as well. Maybe we can start, taking over the world.
Yes.
Thank you very, very much. This is mind blowing. I mean, the
Yes.
subject itself, it's like it's already out of this world, and your knowledge of it is simply
Yeah, I started like terrified about the subject, and now I'm super into it. I'm
still
still
terrified.
terrified, but like, yeah.
It is a fascinating subject. Thank you very much, Tiago.